All right. So, Puru, what does Spark? Why do we need Spark, or what is the significance of Spark? Do you remember?
No.
Okay. So, Spark is one of the latest framework which is designed. Okay, it came up because MapReduce was pretty slow. Okay, so they wanted something which works very fast, a framework which can process the data fast on a kind of a near real time kind of. So that's one of the reason why the Spark came out. So it's a very latest development and it's very powerful and it is very useful. A lot of people are using Spark nowadays. So what it does mostly, it works on the same principle of MapReduce, okay? But it does not use the MapReduce APIs and all. So it has its own APIs. The way it works is it distributes the data across the cluster in memory, okay? And
Okay.
it processes them in memory. Okay, so it uses the RAM of the entire cluster to distribute the data in parallel and process them in parallel. Now, in MapReduce, we are using replication of the data to, in case of any failures of the node and all, right? So, in Spark, they have their own retry mechanism. So, they have like distributed RDDs, which is again, they maintain some backup for them as well. Okay, so they don't rely on the backup of the data that HDFS stores. They have their own way of creating a backup. Now, a lot of people ask question that can Spark run only on Hadoop? The answer is no. Okay, it's a framework which can run on Hadoop, which means that it can talk to HDFS to look out for the data. Otherwise, not necessary that it always runs on Hadoop. So even if there is no Hadoop, we can run Spark on our normal Linux or Windows machine as well.
Okay. So it just talks to Hadoop just for collecting data or accessing data. Is that right?
That's it. That's it.
Okay.
Okay, so accessing the data, or even let's say we have installed Hadoop on top of Hadoop cluster, so it will access the resources of the cluster like RAM and everything, right? So we have an option to either go with Hadoop or not to go with Hadoop. So anything is fine. Now this handout material, it's a very detailed material which gives uh, a very good understanding of what is Spark and all. Now it is also a cluster computing framework built on top of Hadoop. Okay. Now while designing this, it was kept in mind that okay, if it can run on Hadoop, that's good. Okay, but it's not like bounded to Hadoop, right? It can run on Hadoop. It is designed to work best to run on top of Hadoop because Hadoop provides a cluster. It provides data which is lying on the top of HDFS. It has a cluster mechanism. Spark also can work on cluster and all, right? So both works well together, but not necessary to have it mandate. It's not mandate to have Hadoop for running Spark. Okay, but if you want to, if you run it, it's always good. So
Okay.
the most interesting part about Spark is like it is at least 10 to 20 times faster than Hadoop MapReduce. Okay, and why it is faster? Because it stores the data in memory and it computes them in memory, and so that's the reason why it is faster as compared to MapReduce. Okay, if you remember in MapReduce, we were not storing anything in memory. We were reading it from HDFS blocks and processing. That's why it was very slow. Okay, so Spark contains two things. One is the normal Spark APIs and second thing is Spark streaming APIs. So Spark streaming is there to go for a real-time processing of the data. In Spark it is a set of APIs which is, let's say some data is there. So you take the data, either you read it from a file or some databases, right? So we have Spark connector for the databases. It can connect to any database to pull the data. It can also connect to NoSQL databases like Cassandra and all. Okay, HBase or
Okay.
NoSQL database, the Spark can connect and get the data. Or normal is like it can get the data from a flat file lying on Linux or from HDFS, right? So it can get the data, store them in memory and process them to give me a faster result. So what does it do? It it can be run on different types of the cluster manager, like it can run on Yarn framework, okay, Apache Mesos framework if you are not going with Yarn. Otherwise, if you are not going with anything, then it has its own standalone uh, framework which it can run on. So that in that case, it will be running on a standalone. It's using its own framework to run the programs. Okay. Now, so it's not hard since it is not tightly coupled with HDFS, so we can store the data on any file system, or even we can store the data on HBase, MongoDB, Cassandra, right? So anywhere we can store the data. Now, what does it do? Everything in Spark is it's stored as RDDs. Okay. Now, what is RDD? RDD stands for resilient distributed data set. So any data set we take, it is termed as a RDD. Okay.
Oh, what is it called again? Resilient
Resilient
distributed data set.
data sets.
Okay.
Okay. Resilient distributed data RDD. So let's say like as we had relations in PIG. So similarly we have RDD. So any data set we term it as RDD. Because what is RDD? It's an immutable distributed collection of the objects. Each RDD is again split into a multiple partitions which may be computed on different nodes. And so it's like if you relate RDD as a file, so a file can be stored across distributed nodes in a cluster. Okay. Let's say I do some computation on that and store the result in. So that result can again be stored on some another RDD. Okay. And that RDD will also be stored across different data nodes. Again, we do some computation on that RDD, and that output can also be stored on RDD. So like this, we can keep on storing the data sets in RDDs and keep on processing them. Now, Spark always persists the RDDs. Okay, so in case it has to do any recomputation, it can always go and rerun that particular RDD that has failed, instead of again computing from the beginning. Since it persists, so we can always rerun the failed step.
Okay.
Right. Okay. So in Hadoop, we were replicating the data for fault recovery, but in case of Spark, no need of the replication. RDD will do the things for us. Okay, so RDD loads the data. Okay, and resilient, which means they can be recomputed again and again. So we can recompute the data again and again.
Okay.
Okay. So RDD can be computed by two ways. As I said, once I load some file, so that we can point it out as an RDD. Let's say some file or database table or anything. So that can be an RDD. Or RDD can also hold the result of some steps that we have already done.
Okay.
Now over here we have a detailed description of how to install the Spark and all. And so we have to just extract the tar bundle and then export the path properly, like set up the Scala home. We need a Scala also over here for Spark, right? So because Spark is uh, developed in Scala and it works very closely with Scala, so Scala is required.
Okay.
We need to set the Scala Spark home properly and then set up some configuration files. And then we need to just need to export some environment variable in like Scala home, worker memory, how much of instances and all of this stuff. Right. So in Spark, again, there is a master-slave kind of architecture. Okay, so the master is known as master and the slaves are known as the workers. So we can define how many workers we want, but master will always be one.
Okay.
Right. So, and then there is a program. It's a Java program for the word count, and then we have there is a program for word count. What we are doing is this is in Java. So the APIs are changed, but the way we do is again remains the same. Okay. I will not take this example. You can always look at this.
Okay.
There is one more interesting example that I have already uploaded over here in a shared drive.
Okay.
Now, if you go to example code, I upload a simple Spark app master. Now in this, again, there's a file steps to run. So what are the requirements? My requirement is to read an input data set. Okay, and then I need to count the number of the time each word appear. Okay.
Okay.
So it's kind of a word count. So the first two step is a word count. Then the third one is how to filter all the word that show up less than a million times, or let's say to any number of times, less than any given number of time. Okay. Less than.
Okay.
So let's say I want to filter out all the words which has occurred less than 3 times or 4 times or whatever, right? So I need to filter it, and then whatever is left out, I need to count the letters in them. Okay, so each word will have letters. I want to count the number of times a letter has occurred in them. Okay, so first do a word count, then do a filtering, and then do a letter count. How many different letters are there in the data set? So tell me, if you have to do this in MapReduce, how would you do this?
We'll need to first merge all the input text documents somehow, and then the mapper would be to run through all the number of words that are there. The reducer would be to eliminate everything that is less than the specified number of count and take the remaining. And in the reducer, the second part would be to count the number of times each letter occurs.
So that will be a two-step process. Okay, we need a two MapReduce job. The first job will read the count. First one will do the simple word count and restore the result somewhere, and then third one will just filter out unnecessary, or like filter out the words which are not repeated less than that time, and then it will do the parsing for the characters and do the count of the characters. Right. So if I have to do that in MapReduce, that will be to MapReduce job to perform this activity.
Right.
Okay, because unless and until I store the result somewhere intermediate, I cannot do the like once the word we have got the word and then filtered out based upon some criteria, because we need to get the count of the characters as well. So we need to again read out the output of first MapReduce job and then extract those words into the characters and do the count of the characters similarly, right? So that is going to be two MapReduce job. But in Spark that is not required. Spark is much advanced as compared to MapReduce. So let me show what we are doing over here. There are two folders, source and data. I'll go to source, main, right? So Spark program can be written in Java, Scala or Python, right? So all the three languages are supported. Right? So, but the most popular one is Scala, because let's say a Java program needs 50 lines, so you can achieve the same thing in just 5 or 6 lines in Scala. And so Scala is much compact as compared to Java, right? So even it's much advanced to Java also. Let me show you
Okay.
how we do in Spark. So let's first see in Java how to do this in Java. And in Java, the first step is am to read. So what we need to do is we need to first import all the required Spark libraries. Like we need to get the Spark, right? Spark conf to get the Spark conf and Spark tuple. So these are some of the libraries that we need to import. These are all Java array, list array, and also these are some Java ones. And these are the Spark ones. Then in the main function, we have to get the Java Spark context. Like we are setting up an app name Spark count and moving it into a context. So this is a Java Spark context. Okay.
Okay.
And then we are taking one final in threshold. So whatever is the argument, let's say I want threshold as 2, 5, 10 or whatever, I'm taking as the first argument. I'm storing it in the threshold. Threshold means like the for filtering out the word count.
Yeah. Number of words. Yeah.
The words are correct, right? And then in Java RDD, so if you see over here we are taking RDDs, right? So these are resilient distributed data set for Java. Tokenized sc dot text file argument 0 dot flatmap. Sorry, so argument 0 is the first argument, which is the file, and argument 1, this is second argument for the threshold value, right? So
Count.
first one is the file. So we are reading the file, okay, and then after reading what we are doing, we are passing a function flatmap. In this, if you see over here, we are taking a new flat map function. So we are passing it on to a mapping function. And what we are doing, we are simply entering an array of, we are splitting up the word with the space. And so each line will be splitted up by a space into the words. And those will be returned to this flat. Okay, so,
Flat map. Yeah.
right, so the entire document will be splitted up into the words. Okay, and it will be stored in a tokenized. This is a RDD, so we have taken it tokenized. So everything will be split up into the words and it will be stored in a tokenized RDD. Then next step is I want to count the occurrence of each word. So what we are doing, we are creating a new RDD with the name of counts. What it will contain? It will contain the string and the integer.
Okay.
Okay, over here it was only a string. Now it will take string and the integer, this RDD.
It's a pair of RDD.
It's one RDD, but it contains two things, string and integer both.
Okay.
Not a pair of RDDs, only one RDD, but two values in.
So the definition says Java pair RDD. That's why I asked.
Oh, okay, yeah. Yeah, so then you can say it's more than one data sets in this. Like it will have both string and integer as well. Okay. Now what we need to do, we need to read this tokenized RDD and then map to pair, and then we have to do a pairing over here. So in this, what we are doing, we are mapping each of the word to 1. Okay.
We are mapping each of the word to what?
To integer 1.
Okay.
Okay. So the way we were doing in our word count, we used to map each of the word as 1. So same thing we are doing over here, we are mapping each of the word as 1 and returning them as a tuple. And then this goes to the reduce by key, and over reducer what we are doing, we are simply, so we are adding up the values. It will return 1 this plus this, right? So what does it mean? Like, let's say this function is getting called for each of the words. So whatever is the value for a particular key, that values is going to be added up for them.
Okay.
So it's like just sum plus plus, that kind of thing.
Right.
Right. So this is a complete map reduce, and it will be getting stored as the counts. Then we have just done the 2 steps. We just got the word count. Now we need to filter out with a threshold occurrence. So we have to filter out with less than some threshold occurrence. Now in this case we will create a RDD filtered, okay, and we'll read the counts, and then we'll use a filter function.
Okay.
Now in the filter again we are creating a new function, and this will be calling. So what we are doing is the second argument tube is the input. So tube dot underscore 2 means second argument. If second argument is the value of that, so for each word we will have the value in this tuple in filter. So if this is greater than equal to threshold, then return, otherwise don't return.
Okay.
Okay, so wherever the word is less than some threshold, those things will not be written. If it is greater than threshold, then those things will be written. Right, so this filter will contain all the words which are greater than the threshold. Then the same program what we are doing, this filter will take this filtered one, and now we need to count the characters. Okay. Now we are taking again one flat map. In this we are calling, so first what we are doing, we are taking a collection of the characters in an array list, right? So s dot underscore 1 dot length. So whenever we have
the first argument,
wherever we have the first argument has length, which means it has some value, right? Then in an array you are converting into a character array that word, and for each of them we are adding them into these characters, right? So this collection of the character will contain, so we are converting a word into character array and storing them into these chars.
Okay.
And we are returning these characters. Okay. Then we are again mapping it over here. Again we are mapping each of the character to 1. Okay, and then we are reducing the same way we reduce the words. So this time we are reducing the characters, which will give you the count of each of the character. We reduce by key. We simply count the occurrence. So that's it. And at the end we are printing character count.
Character count dot collect. Okay.
Character counts R is a RTT, so that we are printing. Dot collect will just collect all the values for it. Collect function will collect all the values for it and across the node, and it will print it. So it's a pretty big Java program that we have. You see, 4 step. It's a pretty big Java program. Right? Now same thing, if I want to do it in Scala, then it can be done in just 4 or 5 lines. Let me show you that as well. Okay, Now Scala, if you are familiar with, then the syntax are much easier. I'm not easy, it's different, but it's much compact as compared to Java. So we don't have to take care of defining all the functions and giving name to the functions and all. It's pretty straightforward. See what we're doing. We are taking one object, spark word count, and we are defining the main function in this. Okay, an argument is an array of the string. Array of the string is the argument, which is a like it can have multiple arguments, right? Which means array of string, like it can have multiple arguments. Then
Right.
we are taking one value sc. So everything in Scala, any variable is printed with val. Okay, so val sc is equal to new spark context. So spark context, we define Java context. Over here we have to define spark context. New spark const, we are setting up a new name. Right, so this is the first name. Any Spark program, we have to do that. We have to set the name of the application and define a Spark context. Then what we are doing, we are defining a variable threshold, which is args1. Okay, so args1 dot to it. So whatever is the first argument, we are converting into integer, taking it as a threshold. Then split each document into the word. This is what we want, right? So then what we are doing, we are taking a variable tokenized and sc.text file. So this spark context or text file, argument 0, the first file, dot flat map. Now this function underscore dot split, so it will split up this file into based upon the spaces. Okay. So we don't have to define a separate function and give some name. Nothing is required. Simply you call a flat map, give an underscore, which means the first argument, dot split. So whatever is the first, like over here it is taking the first argument, this is the only one what we have, name of the file. Right, so that file will be splitted based upon the spaces and it will be stored in tokenized. Then we need to get the count. Then we'll define another variable word count. We are reading this RDD and then we are passing it to the map function. So what we do in map function, we say underscore comma 1. So this will map each of the word to 1. Okay, and then reduce by this plus this. So it will just add up the values.
So each word will be given a value of 1 and all the recursive words will be added to increase the count.
Yes, that will be stored in word counts. Okay. Then filter out the word with less than threshold. So simply we need to take another variable, read this word count dot filter function, and whenever underscore dot underscore 2 is the second argument, which is a count. So whenever count is greater than threshold, that will be filtered out in this filter.
Okay.
And then we are reading this filtered over here. Now this filter dot flat map underscore dot underscore 1, which means each of the word is underscore dot underscore 1, right, to character array, which means we are converting this each of the words into a character array and mapping each of them to 1 and again reducing by the same fashion.
Okay. It's a little bit confusing. I need to look at it a few more times.
The syntax is little this underscores and you need to have some just but see underscore dot over here what we did underscore dot underscore 2, which means the count. So first one was the word, second one was the count, right, key value. So underscore 2 is the value. Whenever the value is greater than threshold, just filter it. The same thing we are reading this filter data underscore dot underscore 1, which is the value of it, which is the word. Okay. Word dot to char array will convert that word into character array, and then we are sending that output into a map function. So map function will read this character array and assign 1 to them, again dot reduce will reduce 1 plus 1, right? So it always starts from here. You read the data from here, do some operation over here, and dot will again take the data from here and do something over here. Again reduce will read the data from map and reduce it like this.
Okay.
So once we have the character counts, we just have to print them. It will be a character count dot collect dot mk string. So it will just for each of the set, it's going to give me the counts. And mk string we just print them in a string format, divided with a comma, so we can distinguish each different character, their count. So program wise, if you see, just 4 or 5 lines of the program in Scala can do my job.
Okay.
The syntax is a little confusing. Scala is a little confusing. It needs a lot of hands on. So Java is, because it's self-explanatory, because everything is given a function name. There is no shortcuts at all. Scala has a lot of shortcuts. Okay, a lot of symbols, new way of writing the program and all. Scala is a little confusing. Java is, again, yeah, there's not much difference, but only thing is it is a little bigger to write the programs in Java compared to Scala. But Scala is more advanced than Java, and it's much compact with less, very few lines compared to Java. Now, how do we run this program? So for running this program, we cannot just simply, the first thing is Java program, we need to bundle that program and using MVN, right? So we need to download all the dependencies also. There are a lot of dependencies for the Spark, which we did not found in running our MapReduce. Okay, so Spark program will have a lot of dependency that needs to be downloaded, right? So the best thing is to go with some bundle tools which can bundle our programs in a, like some packaging tools like MVN or SBT.
Okay.
Okay, so this MVN and SBT and all, what they do, they will read your dependency list and they will download their respective dependencies, and then they will package them so that we can run it.
Okay.
What we need to do over here in this folder, there is also a file with the name of pom.xml. So any, like, MVN reads this pom.xml over here, okay, and it tries to download all the dependencies for it. Okay. So we are in the repository, it's an XML file. So in the repositories, we have to specify what are all the repositories to look out for the dependencies. Okay. So we are specifying, like, these are the repositories where you can get the required packages. And then what is Scala tool? So which version of Scala tool to use, compiler plugin, and also all these things are there. And then at the end there is dependency. So it needs this Scala library and Spark code. So these are the two dependencies for this program. Okay.
Okay.
Then what we need to do, we need to just go to that folder and say MVN package. So MVN has to be first installed before running that. So we need to have MVN, and it can be freely downloaded.
What is MVN?
Maven.
Oh, Maven. Okay.
Build tool, Maven. So it's a build tool. So what it will do, it will read this POM file. It will download all the dependencies from the repository and it will package it. The output will be getting a Spark word counts and whatever we have defined over here. Right, so whatever is the artifactory version, packaging is jar. Right, so this output will be getting in this format.
Okay.
So we'll be getting it will create a target directory, and it will give me a jar file like this. This Maven will keep once all the build is successful. If there is any error issue, it will report it, saying this is the error. Do not find this dependency or some comparison error, whatever. And then for running, first we need to give the input file in the HDFS like we do for any of the MapReduce program. And then Spark gives me Spark Submit API. So what we are saying, Spark Submit, FFN class is the class that we want to run. So com cloud spark word count spark word count.
Mm-hmm.
And then -fn master, it says that like we had name node. So in Spark there is a master. So if we are running in a local mode, I have to give -fn master as a local. And then I have to specify where is my jar file, location of the jar file. Now this jar file needs two arguments. Right? The first one is the input file. So first one is the input file, and second argument is the threshold value that we have. Okay. So it's similar to running a Hadoop jar file, like Hadoop jar followed by name of the class file. Over here, instead of Hadoop jar, we have to do Spark Submit, class name,
Class name.
and then master as local. Target is nothing but a folder which contains this, wherever is the location of the jar file I need to give an argument to it. Okay.
Okay.
And then it will start it and it will give you the result. So now the output will be, since it is system.out.println, so output will be on the console.
Okay.
Both the case we are printing up the result in the output. So we are not storing anything in a file. That should will be on the console. So you want to give it a try?
Yeah, sure.
Right. So we have the steps over here, everything, we have the program code, everything. So Maven has to be installed before that. So what you can do, you can download the Maven tar bundle, which is again freely available from Apache.
Okay.
And put the Maven. So the way we extract, right? Extract the Maven, set the Maven home, put it in the Maven home path, and then the bin folder. So give it a try and see how it goes. Okay, any issues, just let me know.
Okay.
It's a good exercise. It's a good exercise. It will be very good learning if you try this example.
Say that again. I'm sorry, I couldn't hear you.
And so it will be a very good exercise if you can do this.
Okay.
So that's all I had